Hello, friends. Sorry I'm not here today with you, but I think that this video and packet will help you understand what you need to know about scale factor. So we're going to start with some important vocabulary. So there's a new word that I'm going to teach you for what you already know. So stretching or shrinking the original figure. The fancy academic word for this is to dilate. You may or may not have been to the eye doctor where they put the stuff in your eyes that makes your eyes go in and out like this. That's called dilating because they're stretching and then shrinking. Making a larger, similar version of the original figure, we know that word, that's enlarge. So you're writing this down as I'm writing it. Okay, to make a smaller, similar version of the figure, well, if to make it larger is enlarge, and to make it smaller is reduce. And then the shape you begin with before making any changes to it, that's our original. And we also call that one the pre-image. The new similar shape that is created when a dilation is performed. So that's the one that we're creating from our original, either by stretching it or shrinking it. And that is called our image. And then this last one, this is the big idea today. The number used to multiply the side lengths of a figure to stretch or shrink it to create a similar figure is our scale factor. If at any time you need to pause this so you can get everything filled in your packet, please feel free to do so. And by the way, when you are finished with this packet, this part of it is going to go into the handout section of your binder so that you have it available whenever you need it. Okay, so let's take a look at this down here. So we have an original that is sides of 3 and 15, and we have a new image that has sides of 45 and 9. And today we're going to be working on scale factor. And I know most of you, when you look at this, right off the bat, the number 3 just pops into your head because you saw that both sides on the original have been multiplied by 3. And you're totally right. But the actual math that you did was, you just might not realize it, was you took the image and you divided it by the original. And that's our algorithm. That's our jam. If you can remember image divided by original, you will be set for scale factor. So here's our step-by-step process. The first thing we're going to do is we're going to choose a pair of corresponding sides. So it doesn't matter if I choose the side, the width, as long as I'm using both widths. I can't do my 3 and 45, but I could do my 3 and my 9 or my 15 and my 45. So choose a pair of corresponding sides. And then it's really important to know which one is the image. So this one is the image. And then once we know which one is the image, we're going to divide the image by the original. Image divided by original. Commit that to memory. Okay, so this is our step-by-step process. This is what's going to be really helpful for us to remember what we're doing. All right, so go ahead and flip your page over. So now let's try it. First, we need to choose our corresponding sides. If the shapes are similar, it doesn't matter which pair we choose. I'm going to start with my 3 and my 9, but I'll go back and show you 45 and 15. So I'm choosing 3 and 9 as my side lengths, okay? I know that this is my image, so 9 is my image number, and now I divide. So image divided by original, and that gives me 3. That is my scale factor. Pretty exciting stuff, huh? So if I were to choose 15 and 45, I'm going to put these in parentheses. Just, you don't need to write these down if you didn't already choose that pair. But I'm going to follow that same process. 45 comes from my image, and 15 comes from my original. 15 divided by 45 is 3. So either pair that I choose, as long as I choose corresponding sides, I'm going to get the same scale factor because that's one of the rules about similar shapes. Corresponding sides have the same scale factor. So since I'm going from a smaller shape to a bigger shape, my scale factor is always going to be a number greater than 1. Think about it. If your scale factor was 1, 3 times 1 is 3, 15 times 1 is 15, it wouldn't make a similar shape. It would make a congruent shape. So it has to be bigger than 1. It doesn't have to be a whole number. It could be a decimal. We could have 1.5 for our scale factor. But we're gonna just make sure that we pay attention to make sure that if I'm going from small to big, my number has to be bigger than 1. So if I'm going from big to small, what do you guys think happens? Let's see. So we're going to take a look at these. So I switched the numbers here for us. Okay. So we've got now our 9 and 45 is our original, and our 3 and our 15 is our image. So I'm going to choose 3 and 9. So my step 1, I'm choosing my corresponding sides. Now step 2, my 3 comes from my image. So now this is where kids mess up, because a lot of times people just want to put the bigger number first, but I have to make sure that I'm putting my image first and my original second. So my 3 goes here. 3 divided by 9, well, if I do that in my calculator, I get 0.33, or I could leave it as 1/3. So my scale factor is 1/3. So you can't have a negative scale factor, but if you're trying to go from big to small, your scale factor has to be a number less than 1. So when we go from small to big, our scale factor is a number. You guys know that's not a hashtag, that's a number sign, right? Is a number greater than 1. When we go from big to small, and again, what I mean by that is our original is larger than our image, so we're reducing it. Our scale factor is going to be a number that is between 0 and 1. So it needs to be a decimal or a fraction. Fraction would be fine too. Decimal's a little bit easier because if you want to multiply it out, it's just easier to have that decimal form. Okay, so small to big, it's going to be greater than 1. Big to small, it's going to be between 0 and 1. That's important information. All right, one last thing. You've got to make sure that you don't get tricked by one of your figures being rotated. When you look at these, they don't really look like they're similar, but they actually are. So when you first look at them, just because the 20 and the 3 are both on the top doesn't mean that the 20 and the 3 go together. I actually rotated this one. So step 1, I'm going to take my 12 and my 3, because this one just kind of got rotated this way. So my 12 and my 3 are what are corresponding. My 3 comes from my image. So now I'm going to do image divided by original. So 3 divided by 12. When I put that in my calculator, 3 divided by 12, that gives me 0.25, which makes sense because I'm going from big to small. Okay, so now let's try over here. So now what I want you to do is I want you to pause this, you try it, and then push play and come back to see the work that I've done. Make sure that you're doing it all right. So push pause and then push play again when you're ready, when your work's completed. Okay, welcome back. So my step 1 is to choose a pair of corresponding sides. So this guy's kind of flipped, but I know that this 4 and this 16 go together. So we're going from small to big. That means that we're enlarging, and that also means that my number needs to be greater than 1. Okay, so my small, I'm choosing 4 and 16. So my 16 is my image in this case. This is my original. So I'm going to do image divided by original. That gives me 4. That means my scale factor is 4. If you're not sure and you want to test it, you can pick 2 other numbers. I could pick the 12 and the 3. 12 divided by 3 is 4. So 4 is my scale factor. Okay, now big to small. So in this case, the little guy is my image.